The broadcast is now starting. All attendees are in listen-only mode.
Hey everyone, thanks for joining us for another installment of Isolation Intelligence. Today we have Shad Gwynn and Curtis Jackson of United Enertech. They're going to be presenting on fire and smoke dampers, what they have available, and how to make sure we're using the right types in the right situations. They'll also be showcasing us some of the United Enertech fire and smoke protection solutions. Just a few things before we get started. If you have any questions during the presentation, there's a question box that you can pose those questions, and we will try and get to them at the end. Unless you have one that you feel is contextually relevant, you can raise your hand and we can try and answer those right away. And then we also have the PowerPoints as PDFs available down in the handouts there. Before I hand it off to Shad and Curtis, I'm going to go through a quick presentation on the new updates to the Ontario Building Code in 2020 for fire and smoke dampers. So just so you know, I'm not the authority on the building code, but I'm hoping that I can clear up some of the confusion that we've been seeing lately with in terms of fire and smoke dampers. And like most things in the OBC, a lot of it's left up to interpretation, but hopefully this will get you started. So this is what I'm going to be covering, just a quick presentation. So we'll start with fire separation. Fire separation is the method of creating a barrier between two adjacent spaces so that flame can't spread between them for a set period of time. We won't be diving into the architecture side of this, but fire separation requirements are dictated by Section 3.3 of the Building Code or by the governing standard of that space type. For example, NFPA. Fire separation is accomplished by using rated construction materials in between the spaces. That includes things like drywall or metal panel, and you can also get fire-rated doors. These things are typically listed by UL and ULC, but sometimes standards have different requirements, and it's not enough to just have the UL listing. So fire compartments, which we'll look at a little bit later in terms of how to set up the dampers. Fire compartments are created by using fire separation to separate a space from all of the adjacent spaces. Section 3.3 of the OBC outlines where these fire compartments are required. And if you take a look at the picture in this slide here, the red lines show what a fire compartment is supposed to do. So that room that is currently on fire is completely cut off from the rest of the spaces, giving the people in the adjacent spaces enough time to get out of the building before that flame spreads. So while it's possible to close off fire dampers, they can seldom be completely isolated. You still need to have ductwork running through it. So in that case, we put fire dampers in the ducts to close when they come in contact with high heat. They close automatically and are typically driven by a fusible link that melts when the temperature that they're set to is met. Fire dampers like the one in the picture here are typically low cost, and they come in a variety of types that United Enertech is going to touch on in their presentation. The main point of this presentation is to teach you a little bit about smoke dampers. Smoke dampers are new in OBC 2020 for their requirements. Smoke dampers close automatically when they detect smoke. So they have smoke detectors and are installed on the side of them. And so when the air is smoke laden and traveling through the duct or in the room that the duct is penetrating into, the smoke dampers will close and create the fire separation for the full plane of that wall. Smoke dampers have to meet CAN/ULC S112.1, as you can see in the third point there, and there's 3 classes that standard covers. The smoke dampers have to meet at least one of those classes. Smoke dampers have a significant cost relative to fire dampers, so it's important to use them only where you need them. You can also get combination fire and smoke dampers. From my interpretation of the building code, it's it makes sense that you would need smoke dampers, or sorry, fire dampers pretty much everywhere you need smoke dampers. So in the case that you would need a smoke damper, you would normally put in something like this unless a fire damper was already present. These work in combination, so you have a fusible link and an electronically driven control. So it would close when there's both heat and smoke detected, or one or the other.
Hey, Cam,
Yes.
this is Nathan. I just wanted to, I just got a note from somebody saying they might not be able to hear. I just wanted to maybe take a moment here. If anybody can't hear, just put your hand up at the right-hand side of your screen there and let us know. It seems to be working on my end, so I just don't know if it's not working for others as well. We'll just give everybody about 20 seconds here to try
Sure.
to
Yep. Do
notify
I
us.
sound okay? Do I sound okay to you?
Yep, no, you're fine. Yeah, it doesn't look like we're getting anybody putting their hand up here, so
Okay.
I'll send a note out in the chat so everybody knows.
Yeah, and just so everybody knows, the recording of this presentation will be available on our website afterwards. So if you are having trouble with your audio, you can go to our website after the presentation sometime, probably tomorrow. There will be a YouTube video available. We have a question there, Nate. It might be, oh yeah, they can hear now. Okay, so location of fire and smoke dampers. So fire damper is required on ducts or openings that penetrate a fire separation. This is not new to 2020. I just figured I'd include it just for clarification. And then smoke dampers, it's the location of smoke dampers that is a new clause in the OBC. So smoke dampers are required when the fire separation separates a public corridor. A public corridor is a corridor that provides egress and access to more than one suite. So, for example, in a hospital where you have multiple rooms, the corridor that connects those rooms is considered public. A smoke damper is also required if it contains an egress door referred to in section 3.4. So that section of the building code, you'll have to check that when you're installing a smoke damper to find out if that's required. When it serves an assembly, care and treatment, detention, or residential occupancy, or when it's installed as per the clauses 3.3.1.7, which refers to barrier-free spaces, 3.3.3.5, which covers hospitals and long-term care facilities, or 3.3.4.11, which is retirement residences. So the section for exemptions for fire and smoke dampers has mostly not changed, but they have added a section 3.1.8.8a, which is specifically to smoke dampers. I would urge that you check this when you're putting in smoke dampers to determine whether or not you need them. I won't go through the full list because there is a large list, but this is where you'll find it. So these are the two sections that I referred to earlier. They are for barrier-free spaces and hospitals and long-term care homes. The title on the second one there is an error, but these are where you're going to want to be looking when you're looking at putting in smoke dampers. They have the guidelines for where they're needed and where they're exempt. So I put together a quick example just to kind of give you an idea of where smoke dampers are required. I have a long-term care facility floor plan on the next slide where I have drawn in Microsoft Paint, sorry about that, what it should look like. So I've separated it into 3 fire compartments here. The center one is a single fire compartment. The blue line and the blue boxes here are the penetrations, but they are not through a fire separation. They are only through a regular wall. So in this case, you have your air handler over on the right-hand side. You'll need a fire and smoke damper into the first fire compartment for both the supply and return. You'll need a fire and smoke damper into the second fire compartment. and you'll need a fire and smoke damper into the third fire compartment. And this is for section 3.3.1, sorry, 3.3.3.5 outlines that you need both fire and smoke between the fire compartments in long-term care facilities. So that pretty much sums up what I wanted to share with you about fire and smoke dampers. If anybody has any questions, you can ask them in the question pane there, and I can try and answer them as Shad and Curtis are going through their presentation, or we can answer them all at the end. I don't see any there right now, but if you have any after the presentation, you can email me at cam@odellassociates.com. So now it's my pleasure to introduce Shad Gwynn and Curtis Jackson of Enertech. They're probably going to have a bit more excitement in their presentation than mine did. So without further ado, go ahead, Shad.
Hey guys, this is Shad Gwynn, and I've also got Curtis Jackson here with United Enertech. I'm the Director of Sales and Marketing, and Curtis is our engineering manager. I'm going to share my screen with you guys so that you can see our website. You should be able to see United Enertech's website. Is that correct?
That's right.
Okay. And then we're going to show you a PowerPoint specifically on UL products. So brief history about United Enertech. United Enertech has been around since 1988. We were founded by Bill Tate. Bill was a green-heck manufacturer's rep for about 40 years, and then he decided about 30 years into that to start making dampers, and then gradually started adding more and more product, and he sold his rep firm in 98 and started focusing on manufacturing louvers, fire smoke dampers, control dampers. Until today, we now are a competitor against some of the biggest manufacturers in the industry. We have a full line of louvers, control dampers, fire smoke dampers, and then a lot of other ancillary products that we make for our reps across North America and now also South America. So briefly, I wanted to touch on, give you a tutorial of our website. It's unitedenertech.com. We've got quite a few useful tools on there that are available for engineers to get access to submittal data and installation instructions and things like that. The first thing that I'll point out to you here is the products page. The products page, if you were to click on that, it'll take you to a list of all of our different products. Since we're going to highlight UL listed products today, I want to go ahead and click on that and show you. So there's four main categories, as Cam mentioned, of life safety or UL listed products. In your case, ULC listed products. All of our products that have a UL listing also have a ULC listing. But there's ceiling dampers, also known as ceiling radiation dampers, combination fire smoke dampers, fire dampers. You also have them, hear them called curtain blade fire dampers, and then smoke dampers. So if you were to click on one of those, the most common product that we sell really is combination fire smoke dampers. They kind of dominate the industry here in the United States, and I imagine in Canada as well. But fire smoke dampers, there's really two different styles of blades. There's a 3V blade and there's an airfoil blade. The 3V blade models you can see here all have that. Starts with an FS for fire smoke, 3V for 3V blade, and then AF for airfoil blade. And then we also have a couple different styles. Out of the wall style is an OW, and then FA is front access, where you would have a grill mounted in front of it. Also, to indicate if it's a class 1 linkage or class 2 leakage, there's a Roman numeral 1 for a tighter sealing class 1, and then a Roman numeral 2 for a little bit lighter sealing class 2 leakage damper. This one here is a modulating fire smoke damper. It has a modulating actuator on it. So that kind of gives you a quick tutorial of that. Also, if you were to click on any of these models, it will take you to where you can get all of the instructions, like for example, the submittal sheet of that particular product will load up here, and you can kind of get a look of the way that's going to look. has the performance data and then detail there of the page. But then also installation instructions or some of the other kind of miscellaneous details, like we offer a feature called a momentary test switch. So when the guys that are having to do the testing on the fire smoke damper, rather than having to use a heat gun or just kill the power to the damper, there's a damper mounted right on the damper. It's a momentary test switch where the testing contractor can hold down a button that's red, and it will kill the power to the actuator while they're holding down the button, and then the actuator will unwind the spring built into the actuator and close the damper. And then once it's in that fully closed position, they take their finger off the button, and then the power is restored, and then the damper will open back up. So it's a quick, easy way to test that the fire smoke damper is working. So that's an example of some of the ancillary product additions for fire smoke dampers there. Also, before I get into the UL PowerPoint, I'll show you that we've got a few other tools here. Under the Designer's Toolbox button, we've got options for like Revit files. All of our products, I'm sure a lot of you guys who are design engineers that are on the line here are using DEM files or Revit. All of our products, from some of the precision flow constant air regulators to the remote controlled Bowden systems, are on there. But then we can also go over here to louvers, fire smoke dampers, or UL listed products are also listed there. And you can see all the different Revit files that you can download there. We also have what's called a cross-reference, where maybe if you're used to using a different manufacturer and you haven't used United Enertech's products before and you want to see what our equivalent is to, say, maybe a more common manufacturer in Canada might be like Greenheck. If you were to go to the cross-reference tool, and then you were to select the manufacturer of maybe Greenheck here, and then over here, if you scroll down and select a Greenheck fire smoke damper, such as the FSD 331, and then you click add, it will add our equivalent. So this is our 3-hour fire smoke damper. That's an airfoil blade class 1, and you click on that, and it will take you to the submittal page area that I just told you guys about. So that's kind of a quick tutorial there for how to get around the website for an engineer or architect. For our reps, we also have a pricing portal there. Next thing I'm going to do is kind of hop on here to get into some training about life safety products or fire smoke products. I'm going to click on the site here, and then you guys should be able to see my PowerPoint. Does that look correct?
Yep, you're good there, Chad. Yep.
Okay. So all right. So the products that we're going to talk about today are curtain fire dampers, smoke dampers, combination fire smoke dampers, and ceiling radiation dampers. So the governing bodies that require this, Curtis, you might be able to chime in here. Do you know, are you familiar if it's just ULC 555, ULC 555S?
I believe they go by the same standards. The ULC comes into play when it's listing, when it's the actual label for the product and the classification. But as far as the test standards, it's the same UL 555.
So
and so on.
Yeah, UL 555 or ULC 555 would be fire damper, and then a combination fire smoke damper would have both the 555 and the 555S. So it's both. And then your ceiling radiation or are going to be the 555C and the UL 263. Down in the States here, we have NFPA. There's also SMACNA, breakaway duct connections is included in that. And of course, Air Movement and Control Association does the leakage testing on it, leakage standards. There's also other testing agencies that our products aren't listed in, but there is Enertech and Warnock Kersey, but we have not listed our products in those particular testing standards. So, Curtis, do you want to talk about the breakaway connections?
Sure. So here are some examples of the approved breakaway duct connections. These are connections that are included in the UL standard. So whenever a manufacturer tests a fire smoke damper, they automatically get these standard SMACNA duct connections as part of their approval. Anything beyond this point has to be a special test, which we've done some testing for, and we have a slide on that later in the presentation. Oh, well, this is it. So these are some other dissimilar duct connections. It's basically where you have like a TDC on one side and a roll formed connection on the other, or a slide-on duct flange and a TDC on the other, with metal or plastic cleats. It's something that occurs a lot in the field. But not all manufacturers have this approval, so it's good to make sure of that when you're approving something for installation. Not everyone's going to use those standard types of duct connections because to be honest, a lot of these are a lot easier to just knock the flange on and put a sheet metal screw through. So a lot of contractors use these, and it's a good thing for manufacturers to have approved.
So I'm going to go ahead and jump right into some of the curtain fire damper stuff. A lot of this stuff is probably things that you guys already know, but it can't hurt to be freshened up on it, stuff that we use daily when we're talking about these products. So here's a quick picture there of actually when we had our fire damper test done. This was the horizontal fire test. So again, the fire damper test that we do that's performed on our dampers, you have to have it tested both in a wall, which would be vertical mount, and or in a floor ceiling, which would be horizontal mount. You can see there the picture of the blades before they've even closed on the bottom section, and then you can see them there after they've closed after an hour and a half of testing. You have to be able to pass the test after an hour and a half of roughly getting up to where it's almost at 1800 degrees Fahrenheit. You have to be able to withstand that, and the damper has to stay, what is it, Curtis, a 1/4 inch of a space between the blades and the frame?
It's a 3/8 space per UL 555, yeah. So once the test is over, a UL engineer will come out with a 3/8 diameter rod, and if he can pass that through, so it's got to be less than 3/8, I guess, is the technical standard. So if that passes through the gap, then it's a failure. So there's not a lot of wiggle room there. If the blades open up more than that, even after the hose stream test, it's a fail. So not an easy thing to pass. It's a difficult test to pass.
Okay, you have a 1.5-hour rating, and you have a 3-hour rating. You've also got static systems and dynamic systems. So you'll hear that that term tossed around a good bit, especially when it comes to fire dampers. Fire dampers can be either static or dynamic. Static system, again, is one where the airflow stops when the fire smoke alarm goes off. Dynamic, it continues running when the fire smoke alarm goes off. And again, I mentioned the mounting position is going to be vertical or horizontal. And then I'll go over the different transition types, type A, B, C. And then within C, there's a round, an oval, and then a rectangular. and there's an in the wall and out of the wall style. So your basic fire damper models are going to be static and dynamic. And then you've got these different options here. The way we set up our model numbers is if it's a static system for a fire damper, our model number will have an FD, or it'll just be fire damper FD. Now, if it's a dynamic, it'll have a FDD. If you notice on this chart here, you can actually make a static damper a lot wider than you can a dynamic damper. You can do a larger size. So, for example, here, if you see the chart on the bottom, we are our max single size that's a dynamic horizontal mount is 36 by 36. That's pretty common throughout the industry for that size. After that, a lot of people and us, we jump into what's called a dynamic multi-blade fire damper, which we can then go above up to a 72 by 48 or a 36 by 96. Here's some of the different installation methods. We're approved to have a single-sided or a double-sided angle mounting method. If you notice here, there's a masonry wall, a steel gypsum wall, and you can see the differences in the, try to get my screen here. On the masonry wall, you have to have a retaining angle that goes into the sleeve and into the wall, and also on the steel gypsum wall. Whenever this is done, you also have to have a fastener that goes into the sleeve and into the wall on a single-sided. These are the other styles for when you don't have to have a mounting angle at all. You can actually have a flange-mounted sleeve, and then the fastener that holds it into the wall can actually go through the sleeve and into the substrate. So you're not required to have a mounting angle if it's a grill mounted or out of the wall style. Curtis, you want to touch on the transitions here?
Sure. So type A is basically no transition. It's just the damper size or the duct size, and the blades are in the airstream. Type B is it has what we call a hi-hat or a hood at the top of it that brings the duct size down below the blade stack so that there's a lower pressure drop. So a type B, you actually have to cut the opening larger than the duct size for the blade stack to fit into that opening. And it gives you a lower pressure drop when you use that. Similar reasons for doing the type CR round or the type CO oval, gets the blade out of the airstream and adapts to oval or round shaped duct.
So now we're going to jump into smoke dampers. So we talked about fire dampers, and now this is smoke dampers. So smoke dampers, there's two different leakage classes. There's a class 1 or 2. Class 1 has a leakage rating of 8 CFM per square foot. Class 2 is 20 CFM per square foot at 4.5 inches water gauge of pressure. And also the airflow that can go through the ductwork for our smoke dampers, and our smoke dampers is 2,000 feet per minute. We do have one exception of a 4,000 feet per minute 6-inch water gauge, and it's a specific Honeywell actuator that we have to use on it, but we can do that on our airfoil blade. Standard though is 2,000 feet per minute at 4 inches water gauge. Temperatures are 250 degree or 350 degree Fahrenheit. Again, same as a fire damper, you can mount them in the horizontal position or the vertical position. And you can also add transitions to these. One thing that's different from a fire and a smoke, a fire damper has to be mounted in the plane of the wall, whereas a smoke damper can be mounted up to 24 inches outside of the plane of the wall. The only exception on a fire damper would be that you'd have to have a out of the wall style where the sleeve is wrapped with an installation, or with a thermal blanket insulating it. So again, we have a 3V blade, an airfoil blade, and a true round. The actuators can be mounted in the airstream or out of the airstream. And of course, on the power side, you can do 24 volt, 120, 230, or we even have options for pneumatic actuators. A blade indicator will indicate the position of the actuator, or it can be blade mounted. And it will show it sends out a low voltage 24 volt signal that can be wired into a smoke alarm, fire smoke alarm panel that will indicate if the damper is open or closed. Here's a quick detail there of the smoke damper, airfoil blade smoke damper. Again, it can be mounted up to 24 inches, and that's the center line of where the blade is in a closed position is what can be up to 24 inches outside of the plane of the wall. So combination fire smoke dampers, like I said, are kind of combining the two. Here's some pictures of a test of a fire smoke damper. Again, the airfoil blade, you see the look there. The purpose of an airfoil blade is lower pressure drop. A 3D blade is just a single blade, so it's going to be a little bit less expensive in cost since it's not a double skin. But again, it's going to have a little bit higher pressure drop due to the design of the blade. And then we also have a true round blade for fire smoke dampers and smoke dampers. Some of the same testing, since it's both a fire and a smoke, you're going to have a class 1 or class 2 leakage, 2,000 feet per minute at 4 inches water gauge, with the one exception that I talked about earlier, when we use a high torque Honeywell actuator to go up to 6 inches and 4,000 feet per minute. The electronic fuse link can be, the actuator can be 250 or 350, and then electronic fuse links can go up to 250. We have standard is 165 or 212 degree, but you can go up to 250 or 250. And then again, you have the horizontal and vertical type A, B, C transitions. And then since it's a combination fire smoke damper, you can do in the wall or out of the wall. It has to be mounted in the wall unless you do an out of the wall thermally insulated blanket on it. So the 3V blade, airfoil blade, true round, and then we also have a modulating actuator that I showed earlier on our website. That's so that a fire smoke damper can be used as a balancing damper or control damper at the same time as a fire smoke. You can kind of eliminate a control damper in that situation. This is sort of the bottom one here that shows a canted installation. Curtis, you want to describe that to them for us?
Sure. So a canted installation is basically where it's a round damper that's had to be turned so that the actuator is not straight up and down. So usually this occurs either with quick installs where the installer was in a hurry and didn't get it in straight. And if that happens, if you have canted installation approved, depending on the angle, I think ours is 30 degrees. So it can be 30 degrees off zero and it's still approved for that installation. So it can be for quickness of installation and also if something is in the way, if there's an obstruction there, it gives you a little bit more versatility when installing the damper. So you can move the actuator out of the way if there's a pipe or something going through the wall.
Thanks, Curtis. Here's a detail. I'll let Curtis explain this. It just kind of shows you the typical installation.
Yeah, so typically, with a 1 hour firewall, you have a 4 3/4 stud there, including the layer of drywall on each side. And then you have 1.5 inch of space for retaining angles on both sides, if just in case both retaining angles are used. And then you have the actuator mounting area and the breakaway connections on both sides. this is how we determine our standard sleeve depth based on, a standard, most common wall depth. Anything outside of this particular scenario, we would be adding to our sleeve depth. So it's important to know, if a wall is deeper, to order a deeper sleeve, or a specified deeper sleeve.
So our final product that we'll mention here are ceiling radiation dampers. Not as much to them as a fire smoke damper. So one thing to note is that ceiling radiation dampers are typically above the diffuser that's in a given space. So it's designed to protect the structure above from radiant heat in the room below. Okay. Typically, the most common is to have a round damper with a rectangular damper with a round transition on it. But also we make round fire ceiling radiation dampers as well.
I want to add something, Chad, if I can.
Sure.
It was on the last slide, but I want to make sure we touch on it. Ceiling radiation dampers are currently only approved for static situations, and we see it all the time where they've been misapplied. You have to, if you're going to use a ceiling radiation damper, the system has to be configured to shut down in the event of a fire, because the damper will not close under a dynamic, pressurized duct.
That's a great point. I forget, sometimes we get questions for that, but it doesn't technically exist. This on the bottom here, one thing I will point, approved, it says that we're approved with a steel or aluminum grill or without a grill. That's one of the things that we have on our ceiling radiation damper for wood truss applications. See there the detail of the ceiling radiation damper above the ceiling. Typically, the wood truss system is going to be, we're required for ours to be mounted into a plenum box with either a round or oval inlet on the side. These are our ceiling design numbers that we're approved for. Again, all this information is on our website as far as the ceiling design numbers and all of that. It's definitely important to see, which ceiling design is being used, and then making sure that you're using the correct ceiling radiation damper for that application. Curtis, you want to describe maybe what's going on here in this picture?
Yeah, so this is a boot rail installation for a wood truss ceiling radiation damper. Basically, these can be provided by United Enertech, or you can get them, the contractor can get them or make them depending on what capabilities they have. But it's a really easy and quick installation. Not all manufacturers have the approval for it. It has to be tested to get the approval. But basically, it slides onto the plaster flange. There are no fasteners at that area, and there's 4 fasteners that go through the boot rail into the wood stud or into the wood truss rather, and that's all that holds the damper up. So very quick and easy installation that it's applied before the drywall. But it's so fast. I actually installed that one when we did the test.
So that pretty much wraps it up as far as our PowerPoint here goes. I hope that we didn't go over too much in the time, but if there's any questions at all, please let us know.
So
Nathan,
we do have one question here, Shad.
Okay.
We have a question. Do you have smoke dampers to provide airflow from a pressurized corridor into a suite? I believe you touched on this with control dampers. And the follow-up is, could they be connected to the fire alarm and operated by the fire alarm?
Curtis, you think maybe you could answer that?
Run that question by me one more time. I'm sorry.
So can your control dampers, your smoke dampers, which function as control dampers, be connected and operated by the fire alarm?
Smoke dampers can be connected to the fire alarm system, yes.
Okay, and I actually had a question myself. When would you use a smoke damper versus a combination fire and smoke damper?
It's more for containment rooms and for smoke exhaust systems. So if there's no firewall that's requiring a fire rated damper, then that's when you would use just the smoke damper.
Okay, I'm just going to pose that first question again. I think I misread it there. Do you have smoke dampers to provide airflow from a pressurized corridor into a suite?
So,
I mean, I think they could be used for that purpose. Smoke dampers can be, they're normally configured to fail closed like a fire damper does, but they can be configured to fail open. They're not modulating, so you can't really vary the airflow or anything like that, but you can have them configured to fail open if that's the intent.
Okay, and another question, are there any fire or fire smoke dampers that do not use the fusible link, i.e. electronic type?
Our multi-blade fire damper uses a meltable fuse link with a spring. It's kind of a torsion spring configuration. And then we have the curtain fire dampers also use that, but any fire smoke damper is going to have an electronic fuse link. Anything with an actuator, basically. So if it has an actuator, it's going to have an electronic fuse link. And unless it's the rare case that uses a pneumatic actuator, and then we have a pneumatic fuse link, which is a very, very rare case.
Okay, and a follow-up from the pressurized corridor question. Usually there is a door undercut. However, the undercut is removed, so therefore another way to discharge from the corridor. How would they be tested, and have they? And they said they have these in the UK.
Okay. I don't know that UL has a test for that. I'm sure that ETL probably has one if it's a European standard. You know, as far as the rating for the smoke damper, it's more or less rated for leakage and airflow and closure. So anything beyond that, you know, as far as exhaust, there's no real data proving that it, you know, would allow so much smoke and so much time or anything like that. That would be kind of a custom situation for us.
And sorry to jump back and forth here between questions, but this is how they're coming in. For the
Sure.
electronic type dampers, where would I install the electronic fusible link?
It comes pre-installed on the sleeve, so it's wired in conjunction with the actuator, and it's in the airstream, so that whenever, you know, if it hits 165 degrees, if that's the threshold of the fuse link, that's when it will pop and cut power to the actuator, thereby closing the damper.
Okay, that's the end of our questions. So if you have any more questions, feel free to email myself or Nathan, and we'll pose them to Shad and to Curtis. One more. Does Enertech make those, the electronic fusible link ones? I believe that you mentioned they do.
Yeah, we do. We make our smoke dampers and smoke dampers have electronic fuse links as standard.
Maybe I'll give it 20 more seconds for the questions to come in. Okay, so I think that's it. I just want to say thanks to everybody on behalf of our team here at Odell, and thank you, Shad and Curtis, for coming and giving this great presentation. I know I learned quite a lot here. And like I said, if anybody has any more questions, feel free to email Nathan or myself. This webinar will be available on our website by tomorrow afternoon. You can go and you can watch the full thing again, and you can also download the handouts that we had here, both the presentation on the building code from me earlier and the one here from United Enertech. Stay tuned for our upcoming isolation intelligence webinars. We have one on Wednesday from Envirid, their HLR technologies at noon. And you'll be getting an invite for that one shortly. All right, thank you, Shad, and thank you, Curtis.
Yes, our pleasure, Cam. Thank you, Nathan. Thanks for everybody being on.
Take care.
Take care.